Okay, Biology 230 at Tuskegee University, you have made it to the final and the fourth video for Module 11. Here I'm just going to take a few minutes to describe and discuss key enzymes in DNA replication. Remember in the parental strand where the two parental strands of DNA separated? Well, that was mainly because of the enzyme helicase. Helicase untwists and unwinds DNA double helix. Now, when the double helix untwists and unwinds, it actually creates some tension. The DNA is not very stable. So to relieve some of the tension created by this unwinding, the enzyme is topoisomerase, and its job is to create some stability due to the unwinding of the DNA double helix. Next, we have the enzyme primase. Primase creates the primer necessary to initiate DNA replication. Well, why do we need a primer to initiate DNA replication? That brings us to our last, but certainly not least, enzyme. That is DNA polymerase. DNA polymerase is going to be adding those nucleotides, those bases, those A's, T's, C's, and G's to the pre-existing chain of nucleotides. It can only do this if a primer is in place. Well, what's a primer? A primer is simply nothing more than a short stretch of RNA nucleotides. So once the primer comes in place and base pairs slightly to the DNA strands to be replicated, then DNA polymerase can come on board and start adding those nucleotides. Now it can only add those nucleotides in the 5' to the 3' direction. Say it with me. 5' to 3' direction. That is the only direction DNA polymerase can add nucleotides to the growing DNA strand. And last, DNA polymerase is more processive in prokaryotes than in eukaryotes. Now, this adding only in the 5' to 3' direction is one reason that you have the leading and lagging strands in eukaryotes. And I want to let you think about why that is so. I'm not going to go step by step for DNA replication. Your book does an excellent job of this in figures 16.16 and 16.17. However, to help you, I have listed two excellent animations that also discuss in detail the mechanisms behind DNA replication. So there's two different videos. There's your book. There's things that you found on your own to help you with this concept and these steps. Now, after this module, you should be capable of doing the following things. 1. Design and analyze experiments that test if DNA is genetic material that programs the operations of cells. Next, you should also be able to recognize the principal components of a virus. This is discussed in your textbook. Next, describe and apply the chemical and physical structure of DNA in relation to its primary cellular role. Yes, that was the train in the background. Next, understand the roles of major enzymes and DNA components in DNA replication. You should also be able to differentiate, yes, and distinguish the lagging strand from the leading strand during DNA replication. You need to also be able to identify common errors and their solutions related to DNA replication. You need to also be able to relate telomeres and telomerates to cellular physiology. Link chromosomal structure to chromosomal function. That's a very key important concept that we'll talk more about in class. You should also be able to readily compare euchromatin with heterochromatin, both in structure and in function, and how they actually facilitate and or inhibit, repress DNA replication. And last, and this is one major concept that I love to talk about, comparing DNA replication in eukaryotes to that in prokaryotes. And with that, you have been fully prepared, I believe, and you're going to fully prepare yourself to master all these objectives. If you have questions, if you cannot do these things well, if you cannot do any of these objectives, do not hesitate to email me. It's ggriffin@mytu.tuskegee.edu. Post questions on the discussion board. I will respond. Feel free to also stop by during my office hours or email me to make an appointment. I hope you have a great day. This is Dr. Griffin signing out. This is the last video for this module. thank you. Have a great day.